Hey everybody, welcome to episode 10 of the DocumentDB Insider Hour. I'm your co-host Chad Tyndall, and I'm joined by my other co-host Karthik. I'll let him introduce himself.
Hey all, this is Karthik Vijayaraghavan. I'm a DocumentDB specialist SA, hosting the show with Chad here. Nice to see you all and meet you all here.
Yeah, it's kind of a bittersweet episode. It'll be my last time co-hosting the show. Karthik's going to take it from here. Probably he'll have various co-hosts with him in the future, and he's going to crush it. But it's been a great ride this last year, hosting this show and talking about DocumentDB, all the new features and ins and outs of it. It's been a lot of fun. So Karthik's going to take it from here, and he's going to crush it.
Chad, thank you so much for starting this show. I think this is a great initiative, and we really will miss you. But we'll make sure that we bring you to this show as a guest speaker to share your knowledge and interact with the team here.
I would love that.
Thanks again, Chad. It was great working with you.
So yeah, he's going to be talking about the well-architected lens for DocumentDB today, and I'll let him take it away from here.
Alrighty, thank you again, Chad. Hey folks, so for those of you that have been joining us in the last few shows, we've been doing this multi-part series talking about well-architected lens for Amazon DocumentDB. So in the first couple multi-part series, we covered performance efficiency, and I think the last one we did reliability. So we'll continue that well-architected lens review for DocumentDB, and today, as a part of the same episode, or as a different episode, but it's the same series here, we'll talk about cost optimization. So again, the objective with this pillar is to see how you can avoid unnecessary cost and how you can optimize so that you can save cost when you're deploying with DocumentDB. So like before, the structure is going to be, we'll talk about design principles, best practices, and some questions that you should ask, to see if you're optimizing for cost or whatever pillar we're talking about. So let's get started with the cost optimization pillar and the design considerations that we'd like our customers and DocumentDB developers and users to focus on. Right. So unlike your traditional on-premises database or even self-managed MongoDB, when it comes to DocumentDB, you can size for sustained load, right? That's the biggest advantage of cloud because like many other services at AWS, DocumentDB's architecture allow you to scale basically you can do the scaling independent of your data volume, and so you don't have to provision additional resources or over provision resources ahead of time. You can just start with whatever you feel is your sustained load and then scale up or scale out as you need, right? As demand generates. And again, since we're talking about cost optimization in a lower environment like dev and test environment, determine if you really need high availability, right? So with DocumentDB, you get high durability even with a single instance. But when you have 3 instances, you get 4 nines of availability, which is great. But do you really need that in a lower environment? If not, then reduce the number of instances, right? Likewise, more often than not, we don't do performance testing in a dev environment, right? So in lower environments, use smaller instances, 1 instance, or if you need 3 nines of availability, go up to 2 instances. So this will help you save cost again, because with DocumentDB, you can scale anytime you want with the predictable time about 8 to 10 minutes it takes to spin up an instance. And DocumentDB also offers this feature, and this is primarily because of the architecture, which has the storage and compute decoupled. It allows you to stop the instances and then start them back up, right? So you can stop an entire cluster, and you can start the cluster again whenever you need, right? Up to 7 days. After 7 days, we auto restart, but you can stop and start it how many other number of times you want. So again, what is a good use case for that? Again, in a lower environment, or even in test environments. If you want to, if you're not working over a weekend, which I presume folks try to keep the weekend to themselves. So in those scenarios, just stop the cluster and then come back on a Monday and start it. You can script it and schedule a cron job around it and not do all that automation. That will help you save costs because when you stop it, you're not paying for those instance price. So that's a good feature, and that's again primarily because of the architecture and how we have decoupled compute and storage. And if you're running asymmetric workload, right, like let's say you have like occasional analytical queries that your back office users are going to be running against your operational database. In those scenarios, just create a large instance that will have basically more compute capacity to support those queries, and then like you can stop them when those back office users are done with it, when those asymmetrical workload life cycle ends, right? So you can just stop those larger instances, and you can save cost like that. And then in one of the design considerations we discussed during performance efficiency conversations was about separating mutable and immutable parts of the document. It's also important cost optimization, because when you separate mutable and immutable parts of the document, you can save on IOPS cost because the document size will now be reduced. Again, let's take an example. Let's say you have like a 10 kilobyte document, but you're frequently updating only 2 kilobyte of that. Just extract the 2 kilobyte into a separate document. Now you're going to be making updates to a smaller document, because when DocumentDB is updating this document or dealing with this document, it's going to look at the document in its entirety. So 10 kilobyte versus 2 kilobyte, always 2 kilobyte is better because it's going to result in lesser IOPS for updating those into the storage volume. That will reduce cost for you as well. So it is important for both performance and cost optimization reasons that you separate immutable and mutable parts of your document. And then if your workload has needs to store images, blobs, PDFs, or whatnot, our recommendation is to store those blobs or the objects itself in S3, which is a storage engine designed for objects, right? So you get high durability and a lot of other advantages with S3. And then when it comes to DocumentDB, you can store the metadata in DocumentDB and then the reference to the document, which is basically a link to the S3 storage in the document. This will again keep your access pretty quick with the document, because the size of the document is going to be small, and you're using the right tool for the right job here: object storage for objects and metadata or documents in DocumentDB. That would be a recommended architecture, and I'll share that in the next slide here on how that would look like. And then always use DocumentDB as an OLTP kind of a system. It's not like a data warehouse or data lake, right? So it's good to implement purge requirements and to archive your data. And when you're doing so, you can use TTLs to delete the documents, which is just doable. That's all supported. But if you want to save cost, because TTL does generate IOPS, and IOPS is one of the pricing dimension, as we'll talk in a bit. So if you want to save cost, you can implement a rolling collection strategy, and we'll talk about that as well in a bit. But this will help you to just drop the collection, and when you drop a collection, there is no IOPS, and it is performant as well. So using TTL over, using rolling collection over TTL is a better approach. And then DocumentDB allows you to take manual snapshots. While DocumentDB takes automated snapshots, customers can also take manual snapshots, as and when they want. And customers are responsible for the lifecycle management of these manual snapshots. So if you are creating manual snapshots, make sure that you remove the manual snapshots that you don't need anymore, because when you have manual snapshot that is beyond your retention period, you'll be charged on that, so you can save cost. Cost is going to be minor because this is all S3 pricing, so it will be economical, but still, to optimize, you can remove those unused manual snapshots. And DocumentDB follows a high watermark model when it comes to storage for pricing. So if you are performing any data cleansing, do that before you migrate the data into DocumentDB, because if you bring data into DocumentDB and then delete it, you're still going to be charged for whatever was the high watermark or the initial data volume. So do those cleansing outside of DocumentDB. And lastly, some considerations around the billing itself. We recommend that you create billing alerts at 50% and at 75% of your expected bill, and then start with the daily tracking, then slowly graduate to weekly and monthly tracking. Also, it's very important to know that DocumentDB charges at a per second precision, so this helps you to lower the cost, especially if you have spiky workloads where you have to do frequent scale up and scale down. If you have any temporary workloads like the asymmetric workloads we talked about, bringing in an instance and then dropping it, it's economical because you're going to be paying for exactly what you're using up to a per second level precision. So create those billing alarms and leverage the per second precision to scale as you need. And lastly, use cost allocation tagging. This will help you to track expenses at a very fine-grained level. So you can track how much you're spending on the dev environment, test environment, prod environment, and then you can double-click on it to see how much you're spending on IOPS, on instance, on storage, on backup, and so on. So using cost allocation tagging is a good practice. So those are all our design considerations. We'll double-click into some of these as we go forward here. So let's look at the reference architecture. I kind of briefly talked about this, how using S3 to host objects and DocumentDB to host to store the metadata for those objects is a good practice, right? So in this architecture diagram that you're looking at, the application is writing to and then reading the data from S3 and DocumentDB. So application interacts with both of these systems, right? Let's take an example. If the application is reading the data, it'll first read the data from DocumentDB. So it's going to get the metadata and the link to or a reference to the document, right? And then it'll use that link or reference and go into S3 to retrieve the blob or the PDF or the image that was stored in S3. So yes, there are going to be two calls, but this is going to be much more effective and a better solution than storing everything into a JSON document, right? So the benefits here are going to be fast retrieval. The document size is, of course, going to be smaller, so cost is going to be less as well. Of course, storage cost also reduces because of smaller document size. And smaller document size, like I said before, helps with IOPS as well. So you'll be using your IOPS pretty effectively here. All right. So now let's talk about the IO consumption, right? So in DocumentDB, there are 4 different pricing dimensions: IOPS, storage, backup, and the instances. So of all these, IOPS is a dynamic variable here, right? So because instances, it's pretty fixed. You're going to be paying whatever for the instance size you chose. Like T3 medium, for example, is 78 cents per hour. So that is a fixed cost times how many other instances you're running. Storage is 10 cents per gigabyte, so you can calculate that. Backup is 2 cents per gigabyte. All this is US East 1 pricing, but it's comparable. Now the dynamic factor is IOPS. So let's dive deep to see what sources are for the IOPS and how we can optimize the IOPS cost. So first of all, an IOPS will be generated whenever you perform any operation between the compute and storage instances. So this is the compute and storage layer over here. Anytime you perform an operation between the compute and storage, this is going to result in an IOPS, right? So each document that is read from or written to DocumentDB can take more than one physical IO, and it's going to depend on how many IOs it's going to take. Is going to depend on document size. For example, a document of size up to 8 KB will take 1 IO for reads, and a document of size up to 4 KB is going to take 1 IO for writes, right? So the sources for this IO includes, some of the I've written it on the right hand side of the slide here. It's basically anytime the reads happen from the storage, that is going to result in an IO. You have index scan going on that can happen and that can result in an IO if the index are scanned from the storage layer. When you create an index or update an index, that results in an IO. When you perform updates, there will be soft deletes happening in the background due to the MVCC pattern, and that will result in IO as well, right? Also, it's important to know that any reads that happen from this buffer cache or the memory layer here will not result in an IO, right? So it's always a good practice, since it's such a dynamic variable and there are many sources that result in it. It's always a good practice to estimate what your IO usage would be by benchmarking and observing the IOs. So you can benchmark and run a stress test and see what your IOs are, and then monitor your IOPS utilization in the billing dashboard, like I was mentioning earlier. If you're hitting that 50% or 75% mark sooner than before, then that there's either the IOPS is high or your workload has changed its pattern or whatever, right? So you can reset the expectation there. So always do that benchmarking and understand what an optimal IO cost is for your workload. All right, so since it's a dynamic variable, and we know that we need to optimize, let's look at how we can optimize. So let's look at it from the query and indexes, and then from a sizing perspective, also how you can optimize it by optimally designing your collections. When it comes to indexing and querying, right? So it's important to know right now DocumentDB does not support compression of data that is stored, or even for the indexes. So when you're creating indexes, be frugal and how you're creating and how many indexes are you creating. And also, when we are working in a lower environment, it is very common for us to create many indexes, but we'll not be using all of them. So remove those unused indexes and so look for opportunities to optimize indexes. So in the performance efficiency pillar, I was talking about how you can create indexes with high fields that are highly cardinal, and those indexes are really, really optimized. So, if you create optimal indexes, their size is also going to be less. So it'll help with cost as well. And also always think about it, right? So if you're having multiple smaller or singleton indexes, is there an opportunity to consolidate and create a compound index? Because one compound index, more often than not, is smaller than multiple singleton indexes. And TTL deletes, I kind of briefly touched upon it during the design consideration discussion. Right? TTL deletes do consume I/O. So you can create a TTL index, and you can say, hey, delete this document when this condition is met. That's great, but it is gonna, when the document is deleted, it is gonna result in an I/O. So to minimize this I/O cost, one strategy that we recommend is to create rolling collections. What is a rolling collection, right? So you can create new collections at a desired interval. Like let's say you create a collection on a daily basis, and you want to store data for 7 days. On the 8th day, just drop the first day of collection, right? So that is basically the rolling collection concept, right? So you write records into your collection that you're creating at a desired interval, and then delete the entire collection when you no longer need it. Now we get it that the downside of this approach is if you have to send separate queries to each collection, and if it spans across collection, then there is an extra effort to query them. But this approach does save IOPS. So again, it's going to depend on your workload, on your retention requirement, on your access patterns. But see if you can design considering creating a rolling collection pattern. And always look for opportunities to optimize queries that are not performing. In the reliability pillar section, I talked about how slow queries can result in a feedback loop causing further slowness. So from that angle, it's important to optimize slow queries, but also from a cost optimization, because if let's say your query is using a collection scan or a union scan, you're scanning more data, and who knows, you may even be scanning disk if you do not have the indexes hosted in memory. So in those scenarios, you're going to generate more IOPS cost, right? DocumentDB has like many features and capabilities. For example, one such a feature is covered queries. So when you're running a query, if you look at the explain plan, you would see that it is saying IX can only, meaning it's doing a covered query. It's basically just going to leverage the index to respond to the query. And if you have all that index in memory, this query is going to be fast. Also, there's not going to be an IOPS, right? So it's a good practice to try to get to that state of using covered queries where possible. And then if you're sorting, right, and if you're using the sort operator in your query, then try to use the sort key as a key in the index, like a suffix key, so that it helps with, it will completely drop the sort phase from the query. So these, again, not only helps with performance, but also cost, because you're scanning less data, you're performing less I/O. So now talking about sizing, right? So instance sizing best practice in DocumentDB is to fit your index and working set in memory. So always set aside 1/3 of the memory for the control plane and DocumentDB processes, and then the remaining 2/3 is available for you. So if you know that your working set is, X GB, make sure that it fits within the 2/3 of the instance that you're selecting. And how do you determine the number of instances? That is completely going to depend on your availability target and your read throughput. Like I said, if you don't need like 4 nines of availability, if you're good with 3 nines, just go with 2 instances. Unlike other databases, we do not require that you have odd number of instances or whatever, right? So again, for durability, even with a single instance, you get high durability with DocumentDB, like I said before. So decide the number of instances just based on your availability target. And if you're anything more than 3 instances is still going to give you the same 4 nines of availability. So why would you need anything more than 3? Because in DocumentDB, you can have up to 16 instances in a cluster. That's going to be primarily to support higher read throughput, right? So decide the instances based on these 2 factors, your read throughput and availability target. And lastly, about collection design. Like I said before, DocumentDB is ideal for OLTP workloads. So it's a best practice to define your data retention period and then delete the older documents. So the per collection limit as of today in DocumentDB is 32 terabytes, which is pretty high. But what we recommend is to keep the per collection storage volume around 5 terabytes. This is, again, just for efficient management of data and indexes. And that's not a hard limit or anything. The hard limit is 32 terabytes. But for optimal use, if you are at 5 terabytes, it helps, with index and data management. And, if the collection grows unbounded, and this is very common, right? As you may start with a workload, as years pass by, months pass by, your collection grows, which is good, right? It's because your business is doing well and you're gathering more data, hopefully, right? So if your collection is growing unbounded, and if you observe that your reads and even updates are happening only for the most recent documents, let's say your collection is 6 months old, but you're accessing always the last 7 days of data, then, and you still can't get rid of the 6 months data because, let's say, your compliance wants you to keep the data for 1 year, then the pattern that I would recommend is to use smaller collections. So you move older data into a different collection, like a cold collection, right? What is the advantage of doing this? Keeping the most recent data in one collection and moving the older data into another collection. This helps you to, with 2 things. One is it helps to keep the most recent data in memory because you're now going to be dealing just with a small collection. And also, when you're performing updates, now only a smaller subset of the data which is in this collection, because updates are at a collection level, the indexes are at a collection level. So the updates are going to be happening to a smaller set of documents and a smaller collection as opposed to a large collection. So it will help you to save IOPS. Right. So again, these are some of the techniques that you can use to lower the IOPS cost, and also all these will also help to increase performance. So they are very closely connected, these 2 pillars in DocumentDB. So some metrics to monitor, cost and the pricing dimensions are generated, right? So IOPS is one of the dynamic pricing dimensions. So there are 4 metrics here, right? So the first 2 metrics, the write IOPS and the read IOPS, right? So write IOPS is basically the log records written on a per second basis to the distributed storage. So any writes, be it insert, update, deletes, are going to result in a write operation to the storage. Read IOPS is basically the pages that are read per second from the distributed storage volume in DocumentDB. And anything, like I said before, anything you have in the buffer cache will not show up in the read IOPS metric because we don't charge IOPS for reading from memory. And volume read IOPS and write IOPS is what you would see in your invoice. So it's basically the number of IOs consumed in a 5-minute window. So you can divide it by 300 if you want to know what is it per second. But this is what you would see in your invoice. So if you keep monitoring these, and if you see this, deviating from what you observed during your benchmark testing, then that's an indication that you should look at it and see how you can optimize IOPS by the various techniques we discussed so far. And this just shows you how you can stop and start a cluster. So you can just select a cluster and go to Actions and choose Stop. It'll just stop the cluster. So you cannot perform any queries, but your data, your storage is still there, right? You're not losing your data. So you can come back and start it and start querying the cluster again once you start the cluster. So when a cluster is stopped, there is no incremental, of course, there's no instance cost, and there is no incremental increase in storage volume. So there's not going to be an increase to your backup cost. The storage cost will continue to accrue, but it is, again, as very, very economical in terms of storage pricing per GB. So this will help you to save cost. And imagine, if you just can stop your cluster and start it just over the weekends, in a 30-day month, 8 days, you're not charged on instances, which is pretty significant, almost a third. So pretty significant savings in cost there. And then, like I said before, create a tag, for your DocumentDB cluster, and then enable cost allocation tagging in the billing dashboard to start monitoring cost for particular tags. So that's all about the best practices. Now let's talk about the questions that you should ask for a given workload, right? So when it comes to cost optimization, start with how does your workload characteristics vary for sustained and peak traffic, right? Again, this is cloud we're talking about, the native cloud service, right? So size for sustained load and scale on demand, right? Can you use smaller instances in lower environment? Can you schedule something to start and stop your instances? So those are all the answers you need to look for when you're looking at this question, right? And then the next question is,
Karthik, do we have any? Is there any sample code anywhere that people can look at for? Let's say they wanted to create a scheduled Lambda or something like that to scale things up and down at specific times.
Scale things up and down at specific times. That's a good question. I know we have a blog to do auto scaling, Chad. Okay. So I can find the link to that. So that will basically look at specific instances, specific metrics, and then you can determine when to scale. So that will have the Lambda functions and everything in it.
Okay. Okay. Cool.
Yeah, I'll try to find that blog and share here in a bit. So yeah, thanks for asking that. And when it comes to analytical queries, if you're using any complex analytical queries, then you see if you can use a dedicated instance for that, and then stop it, right? So use it for a brief period of time, stop it, right? And if you have inefficient queries, make sure that you're optimizing them for performance and hence cost. And then also, again, this is all workload specific. So how often does your application perform update operations, right? If the answer is very often, then look for options to see if you can separate those mutable and immutable portions of the document. What are you storing in those documents? Are you storing blobs? Are you storing images? Then separate that into S3, right? If you have unused indexes, always remove that. That's a check that you should be periodically doing and optimizing. And then, can you move the least access document into a different collection, like splitting into that hot and cold collection, so that you're dealing with smaller collection for updates, index updates, and so on, right? And then purging data. How do you purge older data? Do you even have a plan to purge? If so, how do you purge? Do you use TTL index? Can you use ruling collection, right? And in terms of snapshots, do you have a process to delete those unused manual snapshots if you're creating them? Those are the questions you should ask yourself. And then, when it comes to data cleansing, do you perform data cleansing after migrating data into DocumentDB? So that if that is the case, then see if you can do it outside, so that you don't have to incur that high watermark pricing. And how do you monitor the usage for and cost for DocumentDB? Do you have those billing alarms and do you monitor those metrics like the IOPS metric? Are you using cost allocation tagging to track expenses at a granular level and take actions to, let's say you identify that a dev cluster has been running and nobody's using it, just kill that, right? So why do you want to spend money on it? So it's important to have these things in place, like the cost allocation tags and the metrics, so that you can be aware of what's going on there.
I just posted in the chat the link to the blog post you're referring to. I don't know if you want to pull that up on the screen, not the post, but show people the URL really quick.
Oh yeah, sure thing. Yeah, this one, right? Yeah, this is the one.
There you go. Yeah, it's got all the code that you can use for scaling things up. If you want to set a scheduled Lambda or something like that too.
Cool. Thank you, Chad, for sharing that. Yeah, that's a real good blog, real good information in there. Cool. And finally, how do you meet your cost targets? And so it's basically, how do you select your resource type, right? Select your number of instances by your availability target, your size of instances by your working set requirement, and the queries and stuff like that in terms of compute, so that you're not over provisioned. And I think in one of the I think in the performance pillar, I shared a tool to the sizing calculator as well, so you can use that to determine an approximate size of instance as well. And I'll try to find that sizing calculator here as well once I'm done with this. But let's let's keep going here. So that's about the cost optimization pillar. Well, since we have time, we'll cover our second pillar today. We've been doing one pillar per day per show, but this is like relatively shorter, number of slides. So I thought we'll cover the next pillar, which is security. So for the security pillar, again, here the focus is to protect information and systems, right? So how we are storing data. So how can you protect the data? How can you in terms of access and so on and so forth, right? Like encryption, user access, and so on. So that's what we'll be discussing here. So
you can take the URL off the screen, probably.
Oh, sure. Thanks.
There you go.
All right. So the design consideration for this pillar, right? So when you're storing data in DocumentDB, the data at rest and data over the wire, right? You need to focus on encryption. And in DocumentDB, the default options for security are they adhere to the best practice. For example, the data at rest is encrypted, and you can choose to disable that encryption, but we recommend that you keep it. And for data over the wire, you can, again, there's a parameter group option that you can select to enable or disable it. The default is again enabled. So all security best practices are enabled by default. And also DocumentDB is a VPC only service. So this VPC isolation provides you further security. And then you can define security group and determine who are allowed to access your DocumentDB cluster. So for example, you can define a security group and say, just this application server or this group of application servers belonging to a security group can interact with DocumentDB over port TCP, port 27017 using TCP protocol, right? When you do this, you're basically creating an inbound rule and explicitly telling DocumentDB that just accept connections from these set of application servers. So you're minimizing your surface area of attack to the data that you're storing in DocumentDB and the entire DocumentDB cluster as well. And when you create a cluster, you get a master credential, but use role-based access control. DocumentDB has role-based access control feature, so use that and create users with fine-grained access to the data. Avoid using master credentials, just sharing that widely, right, for obvious reasons. And then when it comes to username and password, let's say you created these fine-grained users. Now, when your application users are using them, it's always a good practice to isolate those credentials into an external system, right? It could be any external system, but I'll talk about one that DocumentDB natively integrates with in a bit. But again, this helps you to avoid those accidental deletion of credentials into your Git or any other source control system that you're using, the version management systems. And then leverage audit logs. So DocumentDB supports auditing. Auditing is built in, and we do DDL auditing today. So leverage those logs and see if you can look for patterns and create alarms, right? So you can, for example, say if somebody is logging in like in 10 seconds period, logging in 20 times, is that a bot, right? Can you look for those patterns in the audit log and then trigger an alarm so that you can proactively take some action? So use the audit logs for those reasons as well. And then use IAM role or user to create DocumentDB resources. So when it comes to creating a cluster or creating a DocumentDB instance, you can use these IAM users to control that, right? For example, there is a role called Amazon DocDB console full access in IAM. So you can have your user assume that role for console access. And if you want to automate security best practices, leveraging AWS config by using the manage and custom rules that AWS config provides is a good idea. This will help you to enforce compliance and standards. And I have a blog coming up on that very quickly in a few weeks from now. So it's a little bit more advanced in terms of how you can automate security practices. But it really helps, especially for large enterprises where multiple people are going to be creating cluster. How do you enforce compliance and standards, right? So AWS config provides you good ways to do that. And we have some interesting CDK code samples that are coming up with that blog. So watch for that. All right, and let's double click on some of these best practices and design principles here, right? So to encrypt data at rest, DocumentDB integrates with KMS, so you can leverage that native KMS integration, and you can use with KMS you can use AWS provided key or your own customer managed keys, right? And it supports symmetric key only because customers want to rotate these keys, so it's symmetric keys. KMS will allow you to implement its key rotation policy. So if you are using either your key or AWS provided key with KMS integration, you can leverage those key rotation policies and other advantages that KMS provides. And for over the wire, again, TLS is enabled by default. You can choose to disable in the configurable cluster parameter group, but we recommend to keep it, and we recommend to use TLS version 1.2 and above. And then for role-based access control, right? So always create users with least access privilege. And then to isolate those credentials, DocumentDB, again, being a native AWS service, integrates with Secrets Manager. So you can leverage that integration, and I'll show you a reference architecture just in a bit here. This will help you to isolate the credentials, so your application will not have username, password, or anything. And you'll see how that will work in a bit here. And using those IAM resource level permission, you can determine who within your organization, assuming everybody is in the IAM, who of those can create resources like cluster, instance, and so on, and who just has, let's say, read-only access or whatnot. So you can determine that using the IAM resource level permission. And DocumentDB, as you might have seen in the previous pillars, right, integrates with CloudWatch for monitoring. So you also, in addition to monitoring the DocumentDB metrics, you can publish the audit log and the profiler log into CloudWatch so that you can monitor. You can have a unified dashboard and monitor everything in one place. And on top of it, you can leverage log insights to query the log data. So you have the logs in CloudWatch, and then just like how you parse those logs or query those logs in CloudWatch using log insights, you can do the same. And now if you do that on, let's say, on your audit log, you can then write intelligent queries to come up with those spotting those patterns or trends to see, okay, is somebody is a particular user granting too many roles to other users, right? Let's say if that is not what you want to do, you can monitor those kind of things by writing appropriate log insight queries now on your monitoring log audit logs in CloudWatch. And then DocumentDB also integrates with CloudTrail. If you want to do resource auditing on who's calling what APIs, who's doing what operations, you can do those as well. And like I said earlier, we are a VPC only service, so that limits access to DocumentDB, which generally speaking is a good thing for a database because you don't want it to be wide open. This is the last tier in your application architecture for the most architectures. So keeping it less exposed is always better. And when it comes to authentication, DocumentDB uses CramSHA-1 for password authentication. So those are some of the options that are available for you to use. And now we'll look at how you can implement these, right? For example, when you're creating a cluster, the first screenshot over here tells you that you can select a VPC of your choice. You can define a security group, and the option to enable encryption is selected by default, right? And you can key thing to note here is the VPC selection and encryption option, right? Whether you're leaving it enabled or you're going to disable it. This can be done only during cluster creation. Now, TLS can be disabled via parameter group. You can do that even later after the cluster creation, but on-disk encryption and VPC selection can happen only during cluster creation time. So if you want to change that, you'll have to rebuild the entire cluster. And when it comes to the security group configuration, so you can define a security group for DocumentDB for the cluster you're building. So you can say that, okay, here in this example, right? So you have a DocumentDB cluster which has its own security group, and to this security group's inbound role, you would say, hey, this application over TCP protocol and 27017 port can interact, right? So this will allow only this set of application from the security group to talk. Nobody else can interact with DocumentDB. So just shut down the access to every other application that do not require access, and limit the surface area of attack like that. And then here is what I was referring to in terms of sample reference architecture to isolate credentials. So you can, in this, right, what you would do is you'll go to Secrets Manager, you'll create a token, and you'll say, this is my DocumentDB credentials. From an application perspective, all that the application needs to do is call Secret Manager API, pass that token. When it does that, it gets the username, password, host name, which will be the cluster endpoint, and the port. It will get all those to access. So your application code will be like pretty clean. That is just going to be the token. And say, let's say tomorrow you want that token to point to a different cluster, you can go and make that change into Secrets Manager, and your application will now automatically talk to a different cluster. So you can do those kind of things if needed. And even better, so with Secrets Manager, there is a default function of using what you call as rotation. So you can basically with Secrets Manager, you use the Lambda rotation function that it provides out of the box, and you can say, hey, I want to rotate this DocumentDB credential every 30 days, every 90 days, whatever that is, and it will rotate the credentials for you automatically, and it will also handle the connections in flight during the transition for you automatically. So this is a great option if you want to isolate credentials and avoid just moving things into like accidentally checking the code into GitHub or whatnot. All right, so let's look at the questions that we typically would like our customers to evaluate or assess their workload against. So the first one is, how do you securely operate your DocumentDB cluster, right? Do you have those encryption options enabled at rest and over the wire? Right? Are you using TLS 1.2 for your over-the-wire? If not, we strongly recommend to consider doing that so that you're encrypting your data at both over-the-wire and at rest. And then when it comes to access to the DocumentDB cluster itself, how do you limit them, right? How do you make sure that specific services and applications can only talk to your DocumentDB cluster? So that is basically by your security group configuration. And also, on top of it, create users with least access privilege. So now that okay, this application can interact with DocumentDB, what can that application do? Can they read? Can they read and write? You define users with those appropriate, role-based access control, instead of just giving the master credentials to everybody, right? So, and then how do you, ensure secure application connections to your DocumentDB, cluster? So again, first thing is isolate your credentials. So you can use Secrets Manager. You can use other solutions if you're already using them with MongoDB or any other database that you're using today. That's fine, as long as you isolate your credentials. That is important. And then, you can also make sure that if you have those rotation, it's a good practice to rotate your credentials so that it's more secure. So if you're not using Secret Manager, if you're using an external source like a vault system or whatnot, then make sure that you have that functionality. Evaluate those systems for the functionality to rotate credentials. And then controlling access to the DocumentDB resources itself, which is like who can create a database, who can create an instance, right? Who can perform what operation. That leverage the AWS IAM integration to do that, and define appropriate roles for your users in IAM so that they can perform specific actions, rather than just, again, opening it up. Always focus on that least access privilege. And when it comes to database auditing, right, understand what the auditing requirements are. First of all, if you have an auditing requirement, make sure that you enable audit logging, and then see if you can set alarms for any of those anti-patterns that we discussed about, granting access or authentication or whatever those actions are. And lastly, if you can automate the security best practices, that would be great. So first of all, just use the default values, right? So like encryption or whatnot, use the default values. They by themselves are the best practices. But then you can also use AWS config to enforce compliance so that folks do not accidentally create a cluster with encryption disabled, for example. Right. So those are some of the questions that it's good to ask when you're focusing on your security pillar. So that's all I had for this show. Well, in the next show, we will talk about the last and final pillar, which is operational excellence. But let's take some time for any Q&A or any additional conversation, Chad.
Yeah, I don't see any other questions in the chat. This was nice to cover two pillars in one episode. It's a lot of material.
It is, yeah. I didn't want to squeeze the third one in because I would need a little bit more time for that. But yes, I think folks can look at this. If there are questions, they can always ask us about it. It's these certainly, we've been talking to customers. I've been presenting this to a few of our customers, and the feedback that we have received so far is very, very, very encouraging and motivating, because these questions, especially, when you start talking about this, when you discuss about these questions, customers start thinking about, topics that they probably have missed in their planning or was a lower priority, right? So it really helps to trigger those conversation and thought process.
Yeah, it also seems like the release of the global clusters feature has really unlocked a lot of use cases that were kind of sitting on the sidelines, or maybe they were in development but couldn't go to prod without multi-region support. So that's definitely increased the conversations that we're seeing, I'm sure.
Oh yeah, absolutely. Especially in the last last month's show, we were talking about reliability pillar. There were like a lot of topics about global clusters covered there as well, because that pillar and global clusters kind of go hand in hand, right, for disaster recovery and all that stuff.
Definitely. It's so important to have that data replicated across multiple regions if that's important.
Oh yeah. It's not just to one region. You can configure it to do up to 5 regions. So you can definitely have a very reliable deployment.
Good. All right. Well, that's going to wrap it up for this week. And for this month, really, since we do the show once a month, and we'll be back a month from now on the 3rd Thursday of September. Of course, Karthik's going to be running that show and taking it away from here. So I'm sure he's going to crush it and do a great job.
Thank you, Chad. And thank you, everybody. It was great presenting this to you. I really look forward to see you in the next edition here to talk about operational excellence and bring your questions.
All right. Sounds good. Thanks, everybody.
All right. Take care, guys. Stay safe out there.